CVT hydraulic oil pump. The CVT transmission uses a hydraulic oil pump to clamp onto the steel belt with the pulleys, and move the vehicle. There are pressure ports on various places in this transmission, but don't just connect any pressure gauge into these ports. Use a pressure gauge that's rated for at least 1000 psi. Typical operating pressures can climb to 800 and 900 psi, to ensure necessary clamping force on the CVT belt. If you're measuring pressures, you'll see the secondary variator pulley pressures peak when rolling to a stop, to lower the effective gear ratio. And it's done before the vehicle comes to a complete stop. Once the transmission variator stops rotating, the CVT computer can't change the pulley aperture or ratios, because the variators need to rotate to change ratios. If it were to do that, the variator pulley sides would scratch and get damaged, along with the belt. We've already covered the operation of the variator cones before, so here we'll just concentrate on the hydraulic oil system. But before we proceed, remember that this belt is a pusher, not a puller, which means the primary variator uses the belt to push the secondary variator. This is important. Other CVT designs use a pulling chain, like the ZF CVT, and operate differently. With all CVT designs, pressure is the key component to making them survive the extreme clamping forces. Belt slip within the pulley surfaces will quickly destroy the belt. This is why CVTs have such super high pressures, and special fluids. In general, CVT oil pumps are affected by a drive chain, connected to the engine torque. So, the engine moves the primary pulley, and depending on the CVT manufacturer, a drive chain sprocket mechanism actuates the oil pump itself. CVT oil pumps can be vane, gear and girator-type pumps, which have been common in continuously variable transmissions. Newer CVT oil pumps also have to be compatible with the newer idle stop feature, whereby the engine stops as it reaches an idle condition, then quickly restarts upon takeoff. In trying to improve the power and efficiency of the CVT, engineers are showing interest in other pump types that can better cope with the increasing clamping demands. The higher CVT pressure levels, which enable higher torque and increased variator clamping efficiency, makes the issues of hydraulic system effectiveness and efficiency become increasingly important.